Welcome to EDU World Space.
All right, so if we attempt to use Formula 2, we get a problem, okay? So how are we going to figure this out, right? So we know that the surface area, this is just a well-known fact, surface area of a sphere is 4 pi a squared if the radius is a. So what we do, as always, solve for z, and write this in polar coordinates. We look at our boundary circle. Again, pretty standard. Next thing that we do is for the surface area, we always need to figure out zx and zy. We plug those both into our formula. Okay. We do a little bit of algebra and a little bit more of algebra. So our goal is to get everything in polar coordinates. Okay. All right. So we got everything in polar coordinates. Then we notice that if we were to plug in a, we would get a discontinuity. So that's the whole point of this problem. So we use a limit to get rid of that. Right, we use the limit. And we can use the integration with respect to theta really quickly. Not a problem there. And then we integrate. So I didn't do the integration out here, but you're going to use a u substitution. But we'll end up with something like this. Okay. And then plug in our t's and our bound 0. And then we've got to actually take the limit. But the limit of this as t goes to a is 0. And there's no dependence on t here, so it's just a. So we end up with 2 pi a squared. Now let's go back and say, wait a second, we want 4 pi a squared. So why do we have 2 pi a squared? Well, like I said, we only integrated the top half. Okay? We have z equals plus or minus. This is the biggest mistake that I see with students. It has 2 parts because of this plus or minus. So what we did, we only integrated one part, first part, or top. Okay, so really what we should have had in all of these cases was a 2 everywhere. Okay, so we just take our answer and we multiply it by 2 and we get exactly what we wanted, our surface area.